Every super tall tower on Earth is quietly losing a fight with the air right now, and that surrender is the only reason it is still standing. The top of a skyscraper in a storm does not hold its position. It moves several feet back and forth while people inside sit at their desks and drink coffee. That is not a defect anyone is hiding from you. It is on the drawings. Engineers specified the movement, calculated it, and would be alarmed if it stopped happening. And one of these buildings kept a secret about that movement for 20 years, a secret that had nothing to do with comfort, and everything to do with whether the tower would still be there in the morning. Hold that. Because to understand why it was terrifying, you first have to unlearn the thing everyone believes about tall buildings. Ask anyone what makes a skyscraper safe, and you get the same answer. Strength. Make it stiffer. Make it heavier. Make it refuse to move at all. That instinct is wrong, and it is wrong in an expensive way. A perfectly rigid tower does not make wind disappear. It just refuses to negotiate with it. Wind pushing on 80 stories of glass has to put its energy somewhere. If the structure will not flex, that energy piles up at the base and at the joints, where the whole thing is bolted together. So structural engineers do the counterintuitive thing. They design the sway in. They let the tower bend a few feet at the top and spread the load down through the frame instead of concentrating it. A tall building is closer to a tree than a column. Trees that cannot bend snap. The flexible ones are still standing after the storm, looking slightly embarrassed. But flexibility creates a second problem, and it is not a structural one. It is a human one. Your body cannot feel how far a building has moved. It has no reference. What it feels is acceleration, the change in speed as the floor pushes you sideways and then stops. That is the same signal your inner ear reads on a boat, which is why office workers high up in a swaying tower report exactly what you would expect: nausea, headaches, hanging lights that will not stop moving. Here is the uncomfortable commercial truth nobody puts in the brochure. A tower can be structurally perfect and still be unrentable because nobody signs a lease on a floor that makes them seasick. So the engineers needed something that would let the building keep its useful flexibility while canceling out the part people can feel. The solution they landed on is one of the strangest objects ever installed in a building, and in one famous case, they hung it where the tourists could see it. Taipei 101, completed in 2004, in a city that sits on an active fault line and takes a direct typhoon most years. Roughly the worst possible address for a very tall, very slender building. Suspended in the core, between the 87th and 92nd floors, hangs a polished steel sphere weighing 660 metric tons. It is not a counterweight for an elevator. It is not a water tank. It is a pendulum, held on steel cables, and its entire job is to swing the wrong way. It is called a tuned mass damper, and the word doing the work in that name is tuned. Every structure has a natural rhythm, the period it wants to rock at when something pushes it. For this tower, that rhythm is roughly 6.8 seconds per full sway. The pendulum is tuned so its own swing period nearly matches. Nearly, not exactly, because the mismatch is the whole trick, and it is measured in fractions of a second. The building starts moving east. The ball, being enormously heavy and slightly behind the beat, is still traveling west. 660 tons of steel pulling against the direction the tower is going. Every cycle, all day, without a motor, without a computer, without anyone deciding anything. The building's own motion is what powers the thing that cancels the building's motion. That is the part I find genuinely beautiful. It is a machine with no on switch. In August 2015, Typhoon Saudelor hit Taipei. The damper was recorded swinging nearly a full meter off center, its largest recorded movement, and the operators released the footage. Watch it and the illusion inverts. It looks like the ball is the thing moving. It is not. The camera is bolted to the building, and the building is what is swinging around a ball that is trying to stay put. Now, most of the time, this is comfort equipment. It exists so the espresso stays in the cup and the tenants renew. I want to be honest about that, because the marketing tends to imply otherwise. Most of the time. Which brings us back to the secret. New York, 1977. The Citigroup Center opens, 59 stories, standing on 4 enormous columns placed not at its corners, but at the middle of each side. That unusual base made the tower flexible enough to need one of the first tuned mass dampers ever fitted to a skyscraper, a 400-ton block on the roof, installed for occupant comfort. A year later, in 1978, its structural engineer, William Le Mesurier, went back through the numbers, prompted, by most accounts, by a question from an engineering student who could not make the design work. During construction, some critical joints had been changed from welded to bolted. Cheaper, faster, and by the code of the day, entirely legal. But Le Mesurier had checked the wind hitting the building face-on. He had not checked it hitting the corners. When he ran quartering winds against the bolted joints, the tower failed, at a storm strength that arrives in New York often enough to matter. So welders worked through the nights, floor by floor, sealing steel plates over the joints while tenants came to work in the morning knowing none of it. Emergency plans were quietly drawn up with the Red Cross. And here's the detail that reframes everything. Until the welding was finished, the comfort damper on the roof was load-bearing. The thing installed so people would not feel sick was suddenly part of what kept the building up, which exposed its one flaw. A pendulum on bearings needs power to stay active, so they installed emergency generators because a blackout during a hurricane would have removed the safety net at precisely the moment it was needed. In September 1978, Hurricane Ala tracked toward the city, then turned out to sea. The repair was completed. The public heard nothing about any of it for 17 years. So the next tall building you stand in, remember that its stillness is not stillness. It is a negotiation, running continuously, that you were never meant to notice. And be honest with yourself about the answer. Now that you know the tower is deliberately losing to the wind, would you rather it fought back?